Okay, so thank you everybody for joining. Today, Tonya and I are going to be talking about Essentials extensions versus OEM extensions to help you decide which one will work best for your situation. I'm going to kick us off talking about Essentials, and then I'll throw it over to Tonya for OEM extensions. So just a quick overview of what we'll be covering. I work for Miebach Consulting, so I'm going to talk a little bit about what we do and why we use CET. And then go into why we use Essentials in particular, and then we'll do a demo on how we go about doing that process. And then Tonya will do something similar for Talos and their iCore 3D extension. So to start off, I wanted to introduce Miebach just a little bit. So we are an end-to-end supply chain consulting firm with over 50 years of experience in the industry. We have around 25 offices all over the globe, and we like to say that we can cover any supply chain challenge. So what this looks like is this typically falls into our strategy, engineering, or digital teams, and our engineering team is what's going to use the most of CET. So that's where we do the majority of our design work. You want to flip to the next slide? Yeah. So that process from the beginning, conceptual design of a building all the way to go live. This is what that process looks like and how Miebach supports those various activities. So where we use CET is typically in these first three steps. So to do the concept design and get a general idea of what direction we're going with a technology, with a layout, we're trying to target here a kind of like 75% design here. And then from there, we go into detailed design. And so detailed design is where we really define all of those individual details. We get a better idea of the exact things that are going to be needed for that layout. And then finally, we go into tendering. And so we can use CET to help support making all of our bid documents and putting together RFPs for our clients. So why do we use Essentials over getting manufacturer extensions? So for us, it is primarily about speed, flexibility, and maintaining our reputation of being vendor agnostic. So using generic components makes it so that we can work very quickly without having to wait for exact blocks from vendors or keep a stash of exact blocks from vendors or anything like that. And then from a flexibility standpoint, even if vendors don't have CET, we can use the generics that are available in the Essentials extensions. And then finally, one of our key tenets is being a neutral third party for our clients. And so being able to use these generic components reinforces that policy in our design. So our primary goal here is to give our clients a representation that's accurate enough for them to be able to make decisions with. So from here, I'm going to go into my demo. So let me take over the screen sharing. Okay. So this should, in theory, be sharing my lovely little building here. Can you guys see it?
Yep.
Okay, perfect, great. All right, so to give a little bit of background on this particular project, this is a pharmaceutical client who has a small warehouse, and they are only using a little bit of it. So you can see from this as-is drawing that they only have a few systems in place. They have a lot of empty space over here on this side, and they are starting to grow their business. They're adding a new 3PL operation into it, and so they're changing the requirements for the business. And so they want to make sure they fill out this space in a way that's going to help them continue to operate the way they need to for these new business units. So I wanted to walk through today how we would go about kind of transforming this really quickly to be able to show our clients a vision of what their building could look like in a relatively small amount of time. So one caveat here is typically we would do a little bit more iterative design in our process than what we're going to show here today. But for this, the purposes of this demonstration, we have kind of already built out a general solution. And we're going to walk through how we would illustrate that. So to start things off, this area over here, this is a cooler. So they have chilled products in here and they need more space so that they can do receiving in the cooler as well as packing in the cooler. So the first thing we're going to do is we're going to make this cooler bigger. But to be able to make this cooler bigger, we need to move around some of the existing infrastructure. So in the final design, we are actually going to take this pack line is what this conveyor chunk here is. And this is going to move over to the other side of the building. So using the rectangle selection tool, I'm going to go in here and select all of these different components. And then this is a tool I use all the time, is this position tool, because this I think is the easiest and most accurate way to move components around. So to do this, I'm going to grab this chunk of conveyor from the end here and then move it over to the other side of this kind of dividing wall here. So I think that is worth calling out here too, is these sort of X braces of the building make it a really challenging feature to make sure that we can have forklift paths and other paths go around those. Okay, so now that we have that out of the way, let's also remove these bins here. So we'll replace these with shelving later to have a little bit better utilized space. Oh gosh, there we go. Okay, so now that that is out of the way, we can go ahead and expand our cooler. Oh, actually, one other thing we need to move out of the way here is this racking. So we're going to bring this cooler all the way out over to here with just enough space for a pedestrian walkway between here and the X bracing, right? So I'm going to use the remover tool because I have found that that has been a really easy way to remove racking. And then from there, we're going to remove the system. I'm going to go down here and do that down here as well. Okay, so now we have a nice clean area to work with to be able to expand our cooler. So I'm going to go into walls. And one thing that I really enjoy about continuous walls is I don't have to go in here and redo all the settings. It'll kind of copy them from the walls that I attach it to. So when I add these in here, I can pull it all the way out like that, and it'll go ahead and automatically attach them. And then this is something that took me a little bit to learn, but say I want this wall to extend all the way out to the far side of the freezer, but I want it to go straight. So I can actually line it up with this bottom edge of the freezer and then use my arrow keys. I'm going to use the down arrow here to make sure that that wall goes straight that way. So now I have my wall there, and then I can extend this the rest of the way out to this little one over here. This is the freezer. Okay, so now we have our new cooler and how large that is. And we're going to go ahead and remove the old cooler walls that we're not using anymore. Oh, I also forgot this wall in here. Okay, so again, I'm going to use the remover tool, but I'm going to go in the 3D this time so I can see a little bit better what I'm clicking. So we're going to take out that wall and that wall. And then from here, we can clear out our cooler so that we can sort of reorient how we're doing this for our new cooler. Okay, so next thing we need to be able to get into this cooler. So I'm just going to quickly add a roll-up door here. That to be right about here. Oh. Okay, so now we can get into our cooler. We can see all of our different areas that we have to work with to be able to better build out this building. And this is where it gets really fun for us to be able to start dropping in all of the storage systems we're going to use. So I'm going to start with some racking out here in this ambient environment, and then we'll add some more here in the cooler as well. So for that, we use the Essentials pallet racking extension. And something that we have done at Miebach to help make this a little bit quicker for us is we have created some templates for the pre-configurator. So I'm going to load one of those right now, and then we will use that to draw our racking. So I'm going to load this in. So here we have our 5-high pallet racking with GMA pallets. We've already configured this to be a 42-inch upright. And so all of the different aspects of the uprights, of the beams, that has all been configured to a relatively standard configuration. So we can use this for our concepting phase and then refine it a little bit further later when we get into detailed design. So I'm going to use this racking to fill this area right here. And bring this down about like that. And then it'll go ahead and automatically remove the unit loads where those columns are. And then you can change the settings for that as well, but I like to have it remove the unit loads so we can see, right? So that's the new racking on this side. We want to turn this area into a receiving area, so we're going to go ahead and remove this racking here as well. So now we have our packing here. We have our pallet storage. This is what they'll use for their new 3PL business. And we have our expanded cooler. So now we need to have a little bit more space for them to store their each picks. So I'm going to go into essential shelving. And this is set up very similarly to pallet racking, which is nice to have the consistency. So to do this, I'm going to load in another pre-configuration. So here I have our shelving template. And now we can go ahead and draw these in right near the packing because they're packing up the eaches. And just like it does in pallet racking, it goes ahead and removes anything that interferes with the column. So this building is already looking pretty different just from the few changes that we've made so far. So to kind of continue along the material flow, I'm also going to add our receiving stations over here. So one thing that was very important to our client in this design was having separate areas for receiving and packing so that they don't have too much overlap between the two. So for this, I have relatively recently learned how to use saved favorite blocks. And so for this, I have a receiving station that's fairly generic. It's got some space behind it. It's got a table and a computer. And then I'm going to load this in from my saved favorite blocks. So now I can put in my receiving stations. I'm just going to drop in 3 right here. Make sure they're all lined up. And so now this building is really coming together. So they have a way to receive their product, multiple ways to put away their ambient products. And then now we're going to do the same thing over here in the cooler. So they need a way to receive their products as well as store them. So I forgot to take out this row of racking here. Okay, so we're going to just use our same pallet racking from earlier to fill this top half of the cooler with our racking. Looks like we're only going to be able to get a few of those in there. So at this point in a typical project, we would go in and refine this and kind of play around with the aisle width and find something that makes the most sense for this particular space. And then same thing here for the shelving. We're going to add some shelving in here. Pick it up to here. And the same receiving stations. I could also copy this from where I already have it inserted as well. Okay, so at this point in the drawing, we have kind of brought to life our new plan for this building, right? There's a few, missing details just from the nature of doing a demonstration here. And so now to add a bit more realism to these drawings, I like to put in a good amount of guarding to just really showcase how this looks in an actual facility. So I'm gonna add this guarding in here right now. Oh. And it's being heard. Okay, so when you have your guarding in here, it is like a piece by piece kind of component, right? So you'll have to like piece all of your guardrails together one at a time. So this gives a little bit better picture of where this guarding might be. So something like this. We can also go in here and illustrate where the egress paths are with the new industrial marking tool. So I'm going to use this egress tool right here and put a, let me start right here and put my pedestrian path in here. So I'm just going to pull that all the way down here. And then there we go. So now you can see in here, this shows where that crosswalk is. So this is make sure that we have the clearances we need for egress. I can also change that path to be different colors if I need to and add the floor marking. So if I wanted to show this as a yellow floor path, I can do that. And so I've used this for a couple different things. We can use this for egress marking. You can also use the floor tape to map out things like HEV paths or other automation paths. So if I needed a forklift path in here, I could do that, something like that. And then from there, we can go into showing our clients where the people would sit in here. So this pack line is actually a really good example of where of being able to show how the people would function in this particular design. So I'm going to take this guy and drop him in right here. So in a consulting environment, we are really looking to give our clients the best picture of their future potential facility that we can. And what they typically want to know is how much is this going to cost and what are my people going to do, right? So we want to be able to give them a full illustration of the entire process of their products from entering the building all the way through packing and shipping. So we can then use this 3D model to illustrate all of those different processes. And so we'll use screen captures and renders from each of these different areas to showcase all of the different processes within the building. So with that, that's kind of a day in the life of how we would go about showing a client their new building in CET. So I'm going to pass this over to Tonya to talk a little bit more about how this process would look for an OEM extension.
Perfect. All right, so in a moment, the PowerPoint will come back here and we'll advance to the slide. So about Talos and our extension, Talos is a company that started in 2012 as an independent manufacturing company, branching off or separating from what we refer to as DCS. Our purpose is to innovate equipment solutions to show how business can improve lives and love others. And if you've ever interacted with anyone from Talos, hopefully you see our purpose coming through in your interactions with each of our employees. We began with the I-Core 3D extension in 2019. At that time, Essentials didn't exist. So all the information that Claire was just covering was not a part of CET at that time. So you may wonder, why create a custom OEM extension? First of all, it allows you to define specific product logic, rules, and constraints. And it shortens the sales cycle by enabling quicker and more accurate quoting via BOMs. You can also shorten the engineering cycle by enabling customers to drive the design changes before ordering, using software to generate the 3D layouts. It frees up technical resources so that we can innovate instead of providing the routine support. It makes our brand and workflows central to the user experience. It reduces errors in configuration, and it highlights our capabilities. So I wanted to jump into an OEM extension demo here, and we're going to flip over to sharing my CET. And so in this, first of all, I want to point out that Talos has developed 3 unique extensions. We have our, what I call our generic or general extension. We have something called a parcel extension, which focuses on conveyors and chutes. And we have an MDR extension, which is actually in the final steps of beta testing right now. So first of all, I'm going to jump into our parcel extension. And in our parcel extension, I wanted to point out that we have some global tools available to customers. We're going to hit on these 2 later. I do want to talk about this project information dialog. This is where a customer can go in and set up all of their project information. Hardware, do they want to include extra hardware? What calculations should someone use as default as we go in to lay each of the conveyors in? What manufacturers do they prefer? So I'm just going to flip to a few of these just so that we've got some choices set here. And then I'm just going to go ahead and click OK. There's lots more information here. So once I have this information set and I need to define my equipment type, the way Talos has developed this extension is that we have 3 primary equipment types, and this sets the design characteristics for each of the conveyors and chutes. So I'm just going to go ahead and click Amazon, and it gives the customer or user an alert letting them know that once we select Amazon, you'd have to start a brand new drawing to be able to switch to something else. I'm going to go ahead and click OK. The moment I click OK, you can see here that this fills in all kinds of information, giving me access to many more functions inside this parcel extension. So now that I have all of this open, I'm going to import a layout just to show that we have some different options for importing. So I'm going to import, and I'm going to bring in this CAD starting layout. This happens to be a 2D layout. If I would hit insert, it'll show it here. You can see here there's no 3D in it. So I'm just going to uncheck 3D, but I don't want to spend a ton of time on this. I do want to point out that there's lots of functionality inside here that you can define to be able to bring in both 2D and 3D files. So whether someone is using the 2D file from a customer or something that's already been started, in this case, let's say that it's an existing sort of space that someone has defined, maybe someone like Claire who's just defined, this is a generic layout of what we think the customer needs, and then it comes to us to be able to apply our Talos specific equipment. So now that we have this in here, we're going to come in here to our level conveyor, and we're going to start here in the center and put in a couple of main lines here. What you'll notice is it attached a level conveyor, and the arrow is flowing to the right. So that means my product would be going to my right. I need my product to start here and go to the left. So the first thing you'll notice is in this quick properties, I need to reverse this to be 180. So I'll reverse that using the 180. And then I'm just going to come in near this, and you can see that it understands and snaps quickly to the object. And you'll also see in the bottom screen that I have 3D showing up as well. So I'm just going to go ahead and click and place this initially. Once I place the conveyor, you can see that I am able to make some additional changes to it. I'm going to come over to the conveyor tab, and let's say that I want to define this as a mainline 1, and this is the first unit in the main line. So I set this, and you can also see that my elevation, right now it's sitting at 36 inches, but this is supposed to be at 136. So I can come in here and I can add in and change this to 136, which instantly changes and updates my 3D. Once I have the 136 in there, then I'm going to drag this to be full length. So I'm going to drag this all the way over until the end of the unit. And I'm also going to change this to a center drive, because right now under my drive tab, I have an end drive. You can see that this has a center drive instead. So instead of my drive landing here, I'd like it to be here in the middle. So I'm going to switch to center drive, and we have this set up so that it allows us to move the center drive quickly into the location or space that you need that. I can also change the types of center drives. Let's say that I want this to be a drive 50 or drive 51. As I make the different changes, my model is updating for that. I can also define which hand the motor is on. The horsepower is actually being auto-calculated. And I do want to come back and loop on this. So note that this is sitting at 5 horsepower currently. We'll come back and talk about this in a little bit. So now that we have our center drive in there, let's say that I want to change this side guard to be maybe 24 inches. And I can come in and change these individually, or I can say 24 inch and I can do it across an entire unit. Maybe Amazon would like me to change this over the center drive to be 12 inches. So I can go in and I can do that. We'll change this to 12 inch. And so we can make different tweaks to the design, such as shown here. So we've talked about the horsepower. If I click on this conveyor and I come in and I change my calculations, let's say from let's change this from 3,000 packages per hour to 1,000 packages per hour. If I come over here to my drive, you can see that it dropped from 5 horsepower down to 3 horsepower. So this is auto-calculating. The beauty of this is that you can know enough about what's happening in the system, but not really have to have an in-depth knowledge of conveyor design to be able to quickly put all of the things into this conveyor that's needed. The proper flow based on the feet per minute, packages per hour. I can change my speed if I want to change this to 150, let's say. I can make those adjustments quickly and easily. I can also obviously define my elevation, and it's setting up these leg supports, but it recognizes immediately when something needs a K-brace or when it needs an additional support. So we have this first line in here. Let's go ahead and add a CHU coming in here to connect these two. So I'm going to add a spiral chute. And actually, before I do that, I apologize, I forgot to add in my waterfall drop height. Let's say that I want 2 inches drop from off of this conveyor onto my CHU. I'm going to set that here, and I'm going to come into my spiral chute. I don't need to define my rotation because as soon as I click on it, it automatically is inferring my rotation. But what I do want to define is that I want this to be 30 degrees. I know that I want it to be a right hand because it's turning right-handed. And I could define obviously bolted or welded. I can change discharge width, add a discharge guard, etc. I'm going to go ahead and add a waterfall drop height of 1.5 inches coming off of this. And you can see that I have this CHU just added. If I needed to, I could quickly add supports by just automating supports, and it places the supports in there that would be needed. Let's go ahead and add another level conveyor. And the beauty, again, of this is that as soon as I come near the end of the CHU, it understands the 30 degrees that we've turned coming off of the right-handed CHU, and it'll automatically place this. So I'm going to bring this in here, place it, and then as soon as I have it placed, then I can select this, and I can drag it down. This particular conveyor is ending at a 128 elevation. So it's climbing from a 120 initial elevation to a 128 exit elevation or discharge elevation. So I can change that to 128. As soon as I change it to 128, visually I'm getting some reference that this is inclining. I'm also seeing it here. And I can see the pitched incline end drive, and it's saying it's pitching at nearly 1 degree. Now that I have those three in there, let's say that I want to take these three pieces and I want to copy and paste them down to this next section. So I can copy and paste them. I can bring this quickly and easily to the new length. And before I copied and pasted it, I should have switched this to a center drive, but that's okay. I can always make those tweaks later. For the sake of time, we'll leave it as is. So I have my center drive in here, and I'm just tweaking the distance of it. Then let's say that I want to add some T4s. So I've got a T4 transfer here. I can come in and place it on my two locations that you see it on the layout. And it didn't matter which end I place first. On one, I placed the triangular section first. On the other one, I placed the rectangular. And I'm just going to approximate where those are. On this one here, I'm going to say that I want it to be all the way to the end. So now I have my T4s on here, as you can see. Now that I have the T4s, I wanted to show you a quick little trick we have, but first I need to place a level conveyor. I'm going to place a level conveyor here. You can see my angle is wrong, so I'm going to do a 270 to get it to be the correct flow coming up onto the main line. And then I need a 30-inch elevation instead of a 36. If I overlay this, you can see that it's too wide. So I'm just going to use my arrow right to be able to scroll through until I get to the correct width to be able to place this. Now I have this set. And I'm going to shorten this to the end of the end drive. Now that I have this in here, there's this great little tool that we've developed called Insert Incline Tool. We can insert an incline conveyor from one conveyor up onto this T4, and it'll automatically understand that it needs to connect those two and allow me to pass through that T4. A couple of reasons I wanted to place this on here and show you is because you'll notice this is giving me this red conveyor here. And the reason for the red conveyor, you can see that I'm getting a tooltip pop up there that says incline end drive 33.36 degrees. That's way too steep for us to recommend from packages tumbling. So what we would do is if somebody didn't notice it maybe visually on their screen, they also could go to something called project validation. So this project validation is giving us some feedback on some potential issues. The beauty of this is that customers using this can quickly see, hey, I've got a pitch out of range. I need to adjust this. So they can come into here. I'm going to close this for a second. And I can do this from the 2D or the 3D, but I'm just going to drag this pitch until I no longer see that red underbody. So if we only have a couple degrees variation where this is good. And you can see it's still red here. I'm at 18.05. I'm so close right now that if I move this just slightly, it actually will switch out of being that pink, because 18 degrees is an acceptable pitch. So if I came back here to this system validation, you can see that warning went away. There are some other ones like an invalid guard height for T4. So it looks like here it was trying to make some assumptions. It didn't know how to handle this T4 side guard. So I'm going to switch this to 24 for the unit. and rerun project validation, and you can see the error goes away. A couple other things I wanted to point out is we can export this CAD model once I have it. I can export this drawing out, and I can export it out to any type of DWG. So a 2D, a 3D, if I call this test and hit save, then I have my choice of what do I want to export out. I can also filter things. Let's say that I have some sort of platform or additional item that I don't want part of the export process. I can filter things out so that I'm only looking at what I want. In addition to being able to run the validation and export and import that we talked about earlier, we can also do a bill of material. So if I click here and I go to my Talos specific bill of materials, I can either click on something under search article and I can select it and it'll give me information about what is contained in that or what the customer would need to be able to have that entire system. Or I can also click on full bill of materials, generate BOM. It'll take a moment for me to generate this, but once I have it, I can export the BOM to Excel. And once it's exported to Excel, it's easy for me to come in and filter and sort. So each of these things, we talked about mainline 1.1. This is defining based on just that conveyor line, what all the components I would need. So it has all the different aspects. We also have, and I didn't name the rest of these, but we have each of these can be filtered out by product. The last thing I wanted to point out within our extension is that we have the ability to do these build sheets. So under our Talos extension, we have generate build sheets. And if I click generate build sheets, what this will do is it will allow us to be able to see each of these sections individually on a 2D layout. So we can go in and add dimensions, notes. It'll do a parts list for us to be able to have a BOM available at the installation site. So as this is completing here, you're going to notice I've got my 2D here, my 3D, and then paper. So it's going to flip over. And you can see that it generated each of these sections so that we can associate the item number and where it goes with this item here. And we can easily add dimensions, any sort of reference notes that are necessary. With that, that summarizes or wraps up what I was hoping to show you for our Talos extensions, our very custom OEM extensions.